Okay, Algebra 2. The last class we went over how to solve systems of equations graphically, and then I met with you on Zoom and we went over this problem as well. So what we're going to do right now is go over a couple more examples. So for the first one, based on what you see, you notice that both equations are not in slope-intercept form. For the first one, you're going to transpose the x term. You're going to divide through by -6. We're going to end up getting the y equal, and then the negative divided by negative is positive. 3 will go into both of those numbers. 3 goes into 15 5 times, and 3 will go into 6 2 times. So 15 6 is the same thing as 5 halves. And then at the end we see a plus positive 0 divided by -6. We know 0 is neutral, so it really doesn't matter what sign you put at the end. You're going to list your slope and your y-intercept. And we're ready to graph that one. And then we're going to go to the second equation and do the same thing. We're just making sure we're getting them in the right graphing form. I noticed that y obviously is not by itself, so I'm going to have to do some work here. Transpose the 5x, causing it to be negative. The 10 is going to remain positive. I'm going to divide everything by -2. And then when I simplify, I'm going to end up getting y is equal to a positive 5 halves x, and then 10 divided by -2 is -5. And likewise, you're going to divide or list your slope and your y-intercept. And then before we go any farther, we're going to go back and compare our slopes. It's always a good, smart thing to do. Look at your slopes. Both of these equations have the exact same steepness. Then check out your b's. The b's are different. So what that's telling me right now, and I can predict what's going to happen before I graph, is when the equations have the same slope but different starting points, then they're definitely going to have to be parallel. So we're going to finish this up by starting with the first line going to 0 0. Make this graph a little smaller. Okay, we're going to go to 0 0, and then we're going to use the slope of 5 halves, so up 5 and right 2, up 5 and right 2, and then I'm going to go down 5 and left 2. Okay, and then sketch that in. Just noticed I put that last point in the wrong place. We'll try that. Should have moved it over a little bit. We'll try this again. There we go, third time's the charm. I got it finally. Okay, so that's the first graph. Then we're going to go to the second one. We're going to notice that the intercept's a -5. So we can go 5 units below the origin. And it has the same steepness, so up 5 and right 2, up 5 and not 2. And so we're just going to use our straight edge. Try this again. And then we're going to connect it. I think I missed that last point. There we go. And we are going to make the call on what kind of solution it is. So we can see they're parallel, which we could predict that before we started. That means there's no solution. And the vocab word from your notes, the only word that means a system has no solution is inconsistent. And that is it for that one. Okay, example 4. Without graphing, is the system independent, dependent, or inconsistent? Again, just review. Independent means there's one solution, dependent means there's all kinds, and inconsistent means there's no solution. And so without graphing, what we're basically going to do is just take the equations, put them in the right form, graphing form, and then compare their slopes and make the call. Okay, so the first one, I'm going to get 4y is equal to 2x, and then plus 6. I'm going to divide by 4. And then I'm going to simplify to get y is equal to 2/4 is 1/2. And 6/4 is better known as 3/2. So my slope is going to be 1/2, and my b is going to be the point 0, 3/2. Okay, that looks good. And we're going to take the second equation. And we're going to divide by 8. You're going to end up getting y is equal to 1/2 x minus, and then 12/8 is going to be, 4 goes into both of those, so it's going to be 3/2. Okay, and your slope, and your intercept. Okay, so you can see where this is going. Scroll up so we can see this. So again, just like the last problem, we want to make sure we can make a wise prediction as to what's going to happen. These definitely have the same slope, so that means they're either both parallel, or like the system's parallel, or it's the same line. And then you're going to compare the b's. And I noticed that I forgot to bring that negative down, so we're going to attach that there. The b's are different though, so they start in different places. So that means that this problem, without graphing it, I can just make the call that this is definitely parallel. That's just like the last problem. So it would be inconsistent. Okay. Alright. On the word problem for honors that I gave you on the last practice and also for today's practice, just make sure that you find a solution, figure out how to show me how you thought about the problem, but you don't necessarily have to graph it to solve. Okay? Alright.